Let's go through LeetCode 1049. Last stone weight 2. So this question to give us an integer array stones. And say that we're playing a game. And each turn, we can choose any 2 stones and smash them together. And so you say that if the stone weight, for example, x is small equal to y, then it has 2 scenarios that if x equals to y, both stones are destroyed. And if x doesn't equal to y, the stone of x will be destroyed. And the stone weight y has new weight, that is y minus x. So at the end of the game, there is at most 1 stone left because we have do the stones to be merged, right? So 1 by 1. So the last at 0 at most 1. So it let us to return the smallest possible weight of the left stone. And also if there is no stone left, return 0. We know for this question, if we're trying to search, for example, do the search, right? So 1 by 1, brute force, or those kind of DFS, that is a permutation problem, right? So this kind of time range will be out of time. But we can think out of the box, that is for every stone, right? Every stone, instead we merge everyone, right? Everyone. We, for example, we can consider for example, the data of we select this one, right? What we think about is that we want to have the final result to be minimized. So what we can think about that we can give this kind of stone. Each stones have some kind of directions, right? So it's pretty much like for some of those kind of stones, we are set as in group 1. Okay, another half of the stone we set as group 2, right? So if we just like we want to minimize the total last difference. That is actually we're trying to minimize the difference between group 1 and group 2, right? So we can consider, for example, group 1 has a direction to the right, and group 2 has direction to the left, right? Instead of we have the direction 1 by 1, right? Then we consider the stones into 2 groups, and we try to minimize the 2 groups difference. So if we can think about this kind of problem, is that we trying to for these n stones, right? We trying to find the maximal sum, which is target as maximum weight. We select from this n stones, which is target as 2 sum over 2, right? So this will be a 0, 1 backpack problem, right? So the final result, for example, we have dp 2 over sum, right? So the final result will be sum minus 2 multiplied by dp2 over sum, right? Because that means that, for example, this is 2 over sum, right? Minus delta, right? And this is 2 sum over 2, sorry, plus delta, right? So it the difference will be twice. So after this analysis, we can write code. It's if we consider this as their back problem, the code is very easy to write. So we have int a equals to some length, right? So we'll say for int stone stones, we have some, right? Some equals 0. We have some that's equal to stone, okay? So we are going to have int weight equals sum divided by 2. So what we are going to do is we're going to have this is 0, 1 backpack problem. So we're going to have dp equals new int weight platform, right? So what we do is that for int I equals 0 as very smaller than n I plus plus, and for int j equals weight j greater equal to stone, right? And j minus minus. So I have dp j equals max dot max, right? Max dp j and dp j minus cost I and plus cost, right? In the end, what we return is return sum minus 2 multiplied by dp weight, right? Weight. Notice that we return this, right? Instead of if we return this one, right? Weight minus dp weight. This one will lose the precision, right? Because this one, if this, for example, this is 2.5, right? If we convert to int, it will be the weight will be 2, right? So we use this kind of result. Not cost stones. Okay, the time complexity is n multiplied by weight, right? And the space is just we have array of dp weights, right? Space is weights or weights.